next one, let us try to solve a problem. To solve this problem, the question is modulus. We have to find the values of x which satisfy this equation. So to solve any kind of such problems, first we have to find the values of x where the modulus becomes a 0. So there are two modulus in this question. One is modulus of x minus 2 and one is modulus of x plus 3. So I know that at x equal to 2, this modulus becomes 0, and x equal to 3, this modulus becomes 0. So first case, I'll plot the values of x on the new number line. This is 2 and this is 3. So I'll divide the number line into 3 parts. So this is one part, and this is one more part, and this is one part, and I would analyze the equation individually. So for x is less than 2, the first case, so this is part. So this is a given equation. So if x is less than 2, any value of x which is if x is less than 2, that means I'm subtracting 2 from a value of x which is less than 2. So obviously that would result in a negative number. If you don't understand, I said x is less than 2. Consider x is 1. So 1 is less than 2, right? So I'm trying to subtract a number which is greater than the given number. That is, I'm trying to subtract 2 from 1, which would result in a negative number. But if I take mod, that would be positive. So we know the result of this number is a negative. So as we have seen, the property of mod is if you take a mod of negative, it would give minus x. So the output of this modulus would be negative of x minus 2, that is 2 minus x. Okay, so this would be first 2 minus x plus, now I am analyzing this mod. So x is less than 2. Again, I am subtracting a number 3 from a number which is less than 2. So again, this would result in a negative number. So output of this mod will be minus of this number. So minus of x minus 3, that is 3 minus x. So this is equals to 5 minus 2x, which is equal to 1, which is given in the inequality. So implies x can be founded as 4 by 2, that is 2. You can see x is 2. Okay, but what is the condition we took? X is less than 2. Is 2 less than 2? No. So that means this value of 2 which we got is wrong. So that is, there are no values of x which are less than 2 which satisfies this given equation. Okay, so this part of analysis is done. Now let's go to second part. In second part, let us consider the values of x which are greater than 3. This part. Okay, so again this is the given equation. So if x is greater than 3, so what I suggest you to take a example number which is greater than 3. Let us say it is 4. So 4 is greater than 3, and if I put 4 in this equation, what happens? 4 minus 2 is 2, which is greater than 0. So the same would be the case for any values of x which is greater than this number. So I need not apply modulus for this function because it is always positive. So it comes out as same mod of x minus 2 plus. Now again, I'm subtracting a 3 from a value which is greater than 3. So again, it is greater than or equal to 0, which would be, actually it is greater than 0. So again, I can open the modulus with positive sign, which would be x minus 3 equals to 1. That means that 2x minus 5 is equal to 1, x is 3. So again, the value of x which we got is 3, but we assume that x is greater than 3. That means that there is no value of x which is greater than 3 which satisfies this equation. Now we have to consider this case, x is less in between 2 and 3. Okay, so here we didn't include 2 and 3, but here we have included them. Okay, so now again the same case, the same equation. Now I'm considering a point which is less than 3 and greater than 2. Let us say, for example, I take 2.5. So 2.5 minus 2 is 0.5. which is greater than 0. That means for any value of x between 2 and 3, this value is always positive. For x less than 3 and between 2 and 3, this value would be negative, because 2.5 minus 3 is minus 0.5, which is less than 0. That means this comes out as negative. So as you know what to do, this would be, for positive we need not take mod, but for negative we open the modulus with a negative sign, that is minus of x minus 3, right? So this is x minus 2 minus x plus 3, which is equals to 1. So 1 equal to 1, which satisfies the equation. So these are the values of the x which satisfy the given equation. So this would be the answer. Next, let us find the number of solutions of the equation mod x equal to x minus 6. So as I have told you again, so to solve this kind of equations, first find where the mod is there and find the 0 of the mod. So here x equals 0 is a 0. So first let us analyze the value for x greater than or equal to 0. Okay, so for x greater than or equal to 0, modulus of x would be x. So mod x is equal to x, implies from the given equation x, this modulus of x would be x equals to x minus 6. We don't touch this x because it is just x, but we change this modulus of x since it has modulus. So this would be uh, 0 equal to minus 6, which is not possible, right? So x greater than 0, there are no values of x which satisfy this equation. Next, consider the case x is less than 0, and the given equation is this one. So for x less than 0, mod x would be minus x. Minus x equal to x minus 6, implies x equal to 2x equal to 6 and x equal to 3, implies x is greater than x is equal to 3. So it means that you can see it clearly contradicts. X equal to 3 and x is less than 0. We have taken values of x which are less than 0, but we are getting a positive value. That means that there are no values of x which are satisfying this equation simultaneously. So no values of x satisfies this equation. You can check this, like taking an example also. X, let's say minus 5, x is minus 5. So modulus of minus 5 is 5, 5 equal to minus 5 minus 6, not possible. And you can take 0 also. 0 modulus of 0, 0, 0 equal to 0 minus 6, not possible. And x equal to plus 5, modulus of plus 5 is 5, equal to 5 minus 6, again not possible. So you see no values of x satisfies the equation. Okay, let us solve one more equation. Find the solution set of mod x minus 1 by mod x minus 2 greater than 0. To solve this kind of inequalities, first let us consider mod x as a variable y. Okay, now the equation changes to be y minus 1 by y minus 2 greater than or equals to 0. Now what I'm doing is, if you see it properly, this fraction is a positive number. Greater than or equal to 0 means a positive number. So that means that both of the numerator and denominator should be positive, or both of the numerator should be negative. Then only we get the output as greater than or equal to 0. Do you agree? Negative number by negative number will be a positive number, and positive by positive will be a positive number. But if any of them has opposite signs, this would be less than 0. And if any of them has opposite sign, this would be less than 0. So any of them should be the case. So what I'm doing is, now as I know both of them are positive or both of them are negative, so if I multiply them, what happens is positive into positive is positive, negative into negative is again a positive. So that's why I'm translating this division into a multiplication, so that it is easier for me to analyze. But you have to bear in mind that y cannot be 2, because this is our actual equation which has to be satisfied. Here I cannot put y is 2. Okay, so what I am doing is, now this is my equation which has to be analyzed. So for that, what I'm doing is I'm plotting the in the previous video we have seen that how to solve this kind of inequalities. So I'm plotting the zeros first. Y is 1 and y is 2, and for values of y, this is y not x. This for the values of y which are less than 1, what happens to this equation is, let's say we take -5, -5, -1, -4, -6, and this is positive. So this would be negative and this would be positive. You can take as 5 here and check. 5 minus 1 is 4. 4 into 3 is positive. So these are the values. So now I want values of y which satisfy, which are greater than 0. That means these are the values of y that I need. So y, these are the values. So y can be less than 1. It can also be equal to 1 because there is equality, and y can be greater than 2 or equal to. So y is nothing but mod x. So mod x should be less than or equal to 1, and mod x should be greater than or equal to 2. So from our previous discussion, we get x belongs to -1 to 1 here, and x can be greater than 2, or x can be less than -2 here from this discussion. So the final answer would be union of these three. Okay, right. Thank you. Thanks for watching.